Hey everyone, my name's Sean Davis. I'm a content creator for Eclipse-Astro on Instagram. I've been saying on Facebook earlier that I was going to start doing some tutorials on some basic editing in pixinsight. I'll get to Photoshop in another series, but for now we'll go with pixinsight. So first thing you want to do is you want to start by blinking your frames. Oh, by the way, this is NGC 6744. These are a set of one-click observations using the Chile 1's telescope. So you want to blink and just go through the frames. Make sure that there's no obvious issues like an airplane going through, or you have a bad frame, maybe something glitched, maybe there's some star trail, whatever the case may be. Telescope Live is usually pretty good for that. However, they're not 100% perfect all the time. So first thing is you load your frames in. As you can see, I've got a good majority of frames here. And then you just want to apply this to, this way you're viewing them the exact same way. And then you just go, and I use the arrow keys, and I just go through and check just for some like really bad frames. For the most part, these frames were pretty good. By the way, I am doing this in real time as well. A little dust donut in here. There is a way to get rid of that, but I'm doing a basic edit right now, so I'm not going to get into the too complicated edit processes. So they look alright. Good enough anyways. So the next step is going to be the cosmetic correction. So you're going to take that and you're going to add these files. The first step to do is always cosmetic correction, as it can only be done before registration. So select all your files in cosmetic correction. This can be found in processes, all process, cosmetic correction, right here. You want to select an output directory where you want these to go. So this is NGC 6744, and I'm just going to make a new folder and we'll call it CC, cosmetic correction. We'll select that. You can use auto detect. You can play with these settings. I find that for the most part, for most of the data that I'm working with, the default is just fine. You can preview by double clicking, and then you can do an automatic stretch, STF auto stretch, by clicking this button, the nuclear button here, and that'll put a stretch on there, and then you can preview the cosmetic correction like such. And then if you go and you can play with these settings, I don't know how well you'll see it on the screen, but if you play with these, you'll notice you'll see the hot pixels disappearing. This is what cosmetic correction is doing, is removing hot pixels and any kind of like little artifacts and stuff like that that are blatantly obvious. So once you're satisfied there, you just click the blue circle, apply global, and let it run and do its thing. Okay, so as you can see, this is now completed. We can clear that and just close that. Okay, so the next thing I like to do is find out which frame is best to use to register all my frames on. So to do that, you're going to go to Process, All Processes, and Subframe Selector Script. Okay? From there, you're going to add your files. Make sure to select your cosmetically corrected ones. Open that. Now this was done with the chili. So this was a 16-bit camera. And I believe this was 12. Oh, no. I will. Okay, so this was 0.62 arc seconds per pixel. You can find that by going to the Telescope Live right here. You know, here, Telescope Live, Telescope Network, and then you can go to Chili 1, and it is this one right here, 0.62 arc seconds per pixel. From there, we are not going to assign a directory just yet. Instead, we are going to enter this information here and this information here. So this is basically telling you, telling Subframe Selector what we want it to measure and what fits within these parameters. So once you're done there, click the circle, and it's going to go through and measure everything. Okay, so by the movie magic here, it's finally completed processing, and as you can see, we're 43 of 43 approved. Everything is fitting through there, which is pretty good. It's pretty good data. So we're going to find out which one of these frames is the best frame that we can register to. And you can do that by multiple ways. The full width half max is basically the size of the star, and then your SNR weight. These are the two that I try to balance out the best. So I want one with the most weight as well as the sharpest stars. So it's usually a luminance frame. We'll go with this guy right here. So you just remember this number here. This one is 2355. Write that down somewhere, just so you can find it after. Because all these are approved, there's no need to output them anywhere. And you can use this to make your own weights and everything as well, but again, we're going to use this simply. So now we're going to go to star alignment, we're going to go to list or file, and we're going to find that file, which was 2355, this one right here. Open, and add files, and register all these frames together as such, and we're going to pick another directory. I'll name this reg for registered. Registration just means they're aligned to each other based off of the reference image which we had picked. Once that's complete, just click the circle, and there you go. Okay, we're back. So now that these are now all registered to each other, we can start the integration process. Now, the way I do this isn't necessarily the best way, it's not necessarily the right way. It's just a method that I've learned in my experience that has worked relatively well for myself. There is a bunch of other ways that you can do other things. Pixinsight is a phenomenal program for that. So I do encourage you to play around with the settings, learn it, and see what works best for you. But this method does achieve a reasonable result. So we're going to select our luminance frames now out of the registered folder that we just created. So here's our luminance frames. Now you can add drizzle, you can not drizzle. I like to add drizzle, just I find it makes the stars look a little bit nicer. As long as your scaling, your telescope scaling and everything, your image scale is good for your rig that you're using, which with Telescope Live it is, you don't necessarily need to do it. I, however, like I said, do enjoy using drizzle. Open. So now you have that. So here's your settings. Most of the settings are pretty good as default. I do, however, change when I have like a good amount of files. I will change my to Winsorized Sigma clipping. Generalized, extreme, studentized, deviate is another good one. If there's less than 6 files, I'll use percentile clipping. More than 6, I'll use Winsorized Sigma clipping. More than 50, I'll use linear fit clipping. Keep in mind that that's for the amount on that filter, as all this information is mono, so I only have 14 mono filters, mono images. So when Winsorized Sigma clipping, I changed that to Sigma low to 3.5, and Sigma high I changed to 2.6. This is just my thing that I like. Again, play around with it and find which works for you. If you have some really stubborn satellite trails going through your frame or something like that, you can use this large scale pixel rejection and play with these settings to help get rid of that. There is another method, it's a little bit more complex, and that's using the script utilities, and you have to do this before cosmetic correction. But you use linear defect detection, and that will map out dead pixels and like some straight rows of stuff. So if you have a frame that has a dead pixel row, like a defect line, it will map that out, and then you can use that in cosmetic correction. If you go to use defect list, you'll save a defect list, and it'll load all those rows and columns with the defects on there and help remove them in your cosmetic correction process. So once you're done there, just click apply, and it's going to okay, so it provides you with these rejection high, rejection low. You can look at them if you want, but they're not needed, so you can just back those out. This will give you your integration, as you can see, but we're not done yet. The next step is to go to this drizzle, because we are drizzling. We are going to go back, and we are going to select our drizzle files for the luminance filter. Add those in. If you're using a one-shot color camera, do remember to check this box, enable CFA drizzle. This just tells that the Pixinsight that you are using a camera that has a Bayer matrix. So after that, you can just click apply. Okay, so now that that's completed, you can see we get the drizzle weights there, and we have our drizzle integration. You can use an STF auto stretch, and you'll notice that it just made the image bigger. That is perfectly normal. I like to change that to the filter that it is. So this was luminance, and then you just minimize that, close this, clear that, and then that's one. And you'll do the same process for each filter you used. So we're going to go to the red filter, and we're going to add our drizzle files. As you can see, all my files, and you'll see this little D come up when you're adding drizzle. If you're using local normalization files, you'll see another number come here, N I believe it is. Double check, make sure that your settings that you want to use are good, and then apply. Okay, now let's take a look at this one. STF auto stretch. And as you can see, the integrated file is here. If you're happy with it, you move on, and we can do the drizzle integration. Again, drizzling is completely up to you. Sometimes you may need it, sometimes it may be detrimental. So experience will come into play for that. I can't tell you when and when not to use it. Like I said, I like to use it whenever possible. So once that's done, click apply. And here's our drizzle integration for the bread filter. If you're happy with that, rename it to identify which filter you're using, and carry on. Okay, to save you the boredom, I just went ahead and finished off the other two filters. So I wanted to show you the difference between drizzling and not just regular integration. So what I've noticed, when you zoom in and you look at these stars, for this one example, right? And then we compare each of them. If you look, this one seems to be a lot more pixelated, and it's not as nice. I feel that you just get a little bit better star quality when you drizzle. It's not always the case, and it's not always required. Sometimes, like I said, it could be detrimental to do that. For this instance, it's not too bad. But I'll leave the choice to be yours. Again, this is not meant to be telling you how to do it. It's more of a way I do it, and it works. This is geared towards beginners. So now we have blue. So now we have all of our files integrated. What you can do, what some people do, is they save all these masters. Make sure you click XISF file, that's a pixinsight file, 32-bit floating point, and click OK. Saving these master files makes doing any kind of changes later on easier. You don't have to go through the integration process and cosmetic correction. You don't have to do any of that again after you have these masters created. And by the way, I'm doing these in live. I won't be editing these videos, just to show the exact work that I do. I want it to be as real as possible. So now those files are saved. You can do another thing. You don't have to do this. Sometimes it's nice, sometimes it's not so good. But you can make a pseudo superluminance, if you will, image. You just add these master files together to make a new luminance. Make sure you do not do any rejection. It's already been rejected. If you do that, you can actually sacrifice data. And you're just gonna and make sure you uncheck generate drizzle data if you're drizzling, and then just apply these together. Okay, and here you go. Now you can see I have the superlume, which included the RGB data, and the regular luminance. So this gives you everything. Gives you a better true luminance, and a little bit better of an integration. You don't have to do this. Working with just a straight luminance file is fine as well. Sometimes I do this, sometimes I don't. It's purely up to you. So that's how you do image integration and cosmetic correction. I'm going to put a stop here as the video's getting pretty long now. Tune in for my next video, and I will show you dynamic background extraction and how to take your linear master files and turn them into a RGB non-linear image. Thanks for watching, and I hope this helps. Enjoy.